Size is important, variability, repetition. Again, we might do this experiment, a report back to my boss, he'll look at the data, he'll say, let's go at it again. So maybe for 6 months we might continue with laboratory mice, maybe for a year. And then we'll look at the results for that period of time and they'll say, well, it's looking promising, or it looks terrible, so can it? Let's move on to something else. This is where the data has to be thoroughly examined. This is where the statisticians and everybody else comes in and gets their input. And then we come to the other part. There are two important parts of the scientific method. One is the testing, the control experiment part, and the other is forming conclusions. And there's a real misunderstanding about what conclusions are and what they're meant to accomplish. They are objective. An experiment is not done for the purpose of proving you right or wrong. It's not to stroke your ego. It's not to brag. We're supposed to follow the trail where the trail leads. Conclusions need to be insightful. This is where I remember in college when professors graded our labs, they looked at the control part. Everyone's hypothesis was the same because we agreed on that. Procedure was the same. We talked about the control part as a group. Some articulated it better than others. But conclusions are a place where you get to shine. This is all you. You're sitting back in your dorm room, at home, wherever you are, and if you're doing it as a college lab, and you're being very pensive and insightful. And this is where you get to show how thorough you are at looking at the data and looking at where it might be leading. Some people see nothing. Other people see an anomaly and they'll say, wait a minute, what about that? And they'll go, oh, I didn't see that. So professors in college love to see insight, any intuition in this area. All right, in formulating conclusions, again, concise summary, key facts. In a conclusion, you have to understand the conclusion does not have to agree with the hypothesis. I think that's in here, coming up here in just a minute. See if we can get down to that. No. Let's go down and then come back up. There's a, I guess I don't want to do that. Okay, sorry about that. I'm just a little ahead of myself. All right, so what you're doing in your conclusions is you're looking at the data, you are interpreting the data, and then you have to make a decision. Does it agree with the hypothesis? Now, we are so programmed to doing canned experiments where we know the outcome before the experiment's done. I would do 20 or 30 labs a year in high school, and we all kind of know where we're going. In research, that's not the case. Does anyone know Thomas Edison, how many different filaments he tried inside of a light bulb before he found tungsten? 5,000. Do you know Thomas Dyson, as in Dyson vacuum cleaners? British inventor. 15 years and thousands of designs. They asked Thomas Edison, aren't you discouraged? He says, no. I'm one step closer to the answer. I've eliminated all those. Dyson said the same thing. Some people stop just short of the goal. Sometimes in the conclusions, you interact what the independent and dependent variable. You state those terms, you use those terms so that they understand that you've made the connection between what you tested and what dependent variables, what data resulted from that testing. You're allowed to make comments. You're allowed to make suggestions about effectiveness and future experiments. This benefits the next group of people. It may not be the same group, or there may be variations in that group. Now, there's another aspect that's missing in most conclusions. If you're going to be objective, you have to realize that error creeps into any investigation. It's unavoidable. There are two basic types of error that can affect our conclusions. Negative conclusions are those that disagree with our hypothesis. Positive conclusions are those that support, and usually it's somewhere in between. And as we look at these conclusions and evaluate what type of conclusions there are, we need to be looking at the types of error that can creep into a scientific experiment. Here's the toughie: random error. Random error is a type of error that causes the data results to move around randomly. Very hard to identify, almost impossible to eliminate. The other type of error is much easier to identify, and that is called systematic error. Systematic error is a type of error which causes the results to be moved in one particular direction. Under systematic error, there are three types of systematic error that can come into an experiment. The first type is systematic theoretical error. This is the one you don't want to make. This is where you use the principles of science incorrectly. I remember 10 or 15 years ago, some scientists at a university out in Colorado thought that they had a way of producing nuclear fusion like the sun without heat. It's called cold fusion. And they published, these two professors, this information. Well, it goes through peer review. And they found out they had made some huge mistakes in their chemistry and physics, which pretty much ended their careers. So that's one you don't want to make. There were a few instances last year, people not using scientific principles properly. So be careful of that one. Environmental error. If we forget to put the mice in the same environmental conditions, we put one group of mice in a room where the humidity and temperature is the same as the other group, but we didn't control the lighting. One group gets light for 8 hours a day, the other gets 12. Well, that can change results. That's a systematic environmental error. And we have instrumental error, where the instruments we're using are not being used properly. They have not been perhaps calibrated properly. We use double pan balances a lot in science. One of the things I tell students is before you use a double pan balance, you're supposed to tare it. Not tare it, but T-A-R-E, which means to zero it. A little knob on the side, make sure that when nothing's on it, the needle's at 0. If you forget to do that, then all your data is skewed one way. You've made systematic instrumental error. So, to recap, conclusions are analysis of data, insightful, probing, suggestions, and types of error should be considered. You're leaving a trail for someone else to follow, so they don't have to reinvent the wheel and duplicate your mistakes.